So this section is about critical thinking and misleading graphs, which are used in the media and other places, so it's good to be a critical thinker. So for example, let's say that somebody is 5 feet tall and somebody else is 5'11", almost 6 feet tall. So this person is 11 inches taller than that person, but suppose that when the graph was made, they have, here's the two people, one person, other person, and then this is going to be 4 feet tall, this is 5 feet, and then this is 6 feet. So for the first person, they're 5 feet tall, and the graph would go up to here. The other person is almost 6 feet tall, so they would have a graph that goes almost to 6, right about like that. And then this would be misleading, because if you look at that compared to this one is pretty much twice as tall. So if I make a line straight across from there, so basically this second person looks twice as tall as the first person. That would be misleading. And it's because this scale should have started at 0, 1, 2, 3, 4, 5, 6, and then it would have been more accurate. So with this section, like the last, I think it's best if we actually look at some of the examples that they have. So for example number 1. So harness racing, so this is when people ride in a little cart behind the horse. And these are the years, and then these are the times, the records for the 1 mile. And then it says draw a line graph. So a line graph would mean, so these are like the X's and these are the Y's. Sorry, can you see that? These are like the X's and these are the Y's. So this is going to be the horizontal axis and this will be the vertical axis. So down here would be the years, 1921, 1922, etc. 1923, etc., etc. So here's the years. And then with a line graph, over here is going to be the time. So these different times. And then for part A, they said, draw a line graph using 150 as the baseline. So in other words, down here at the base, this stands for 1 minute and 50 seconds. And essentially what they're doing right now is another example of this. So this one, I started the baseline at 4, and then it exaggerated the results. So let's see, 1 minute and 50 seconds, and then 1 minute 51, 52, 53, 54, 55, 56, 57. It goes up to 1 minute and 57, almost to 158. So this would be 1 minute and 58 seconds, etc. All right. So in 1921, it was 157.8, so that's right about here. 1922, it's 157, and 1922 again. So another 1922, so actually this needs to be changed to be 1922 again, and that is 156.8, etc. So by the time that you finish and you get to 2004, then it would be 150.2. So 150.2 would be way down here. And then you connect the dots. So you connect the dots, and basically because this starts at 150 instead of starting at 0, this looks like a huge difference. When it's really an 8-second difference, but this is basically now exaggerated and it looks like a huge difference. On part B, they're then saying now start at 0. So that's where I was saying, like on the last one, if you start the baseline at 0, And then like here is 1 minute, and here is 2 minutes. So then the first one would be 1 minute and 58 seconds, and then 1:57, and then etc. And they go down to 1:50.2. So 1:50.2, by the time you get to 2004, it's going to be like this. So then you would see that, yeah, there's a little bit of difference. They definitely are getting faster, but it's more like this much difference rather than this much difference. That is an over-exaggeration. And what else? So here's the years, and here's the gas prices. Oh, how cute. $1.46 for gas, $1.39 for gas. That's a cute price. Construct a line graph if you were an oil company. Okay, I'm not exactly sure what they mean. So I have a feeling they're talking about, one way you could graph it is an over-exaggeration, and one way you could graph it would be more like reality. So they're then saying, if you were an oil company or if you were a consumer advocacy group. So if you were a consumer advocacy group, you might want to say, my gosh, look at gas has jumped from 146 up to 261. So it's actually this one that I would think that you would want to show an exaggeration. And so for doing part B first, if I wanted to exaggerate it, then I would start at, so that's 139, start at 139, and then $1.40, $1.41, $1.42, 43, 44, 45, 46, 47, 48, 49, etc. until eventually you get to $2.61. And then you'd see the gas price starts at $1.46. And then it goes to $1.39, and then $1.60, and then $1.90, and then $2.31, and then $2.61. So it goes like this. And then if you were trying to argue that oil companies are making too much money, you could then present this graph and say, look at the price of gas has shot way up. Where the oil company, they would say, let's start at $0. Here's $1 per gallon. Here's $2. And here's $3. And then the graph would be more realistic. So first it would be $1.46, and then $1.39, and then $1.60, and then $1.90, and then $2.31, and then $2.61. So the shape is basically the same, but it looks like a much smaller difference compared to this. So this would be part A. Now my point with this was to show you the idea, not to do the whole thing for you. That is part of the homework for you to do that. So then create a 3D line chart. So line chart is what we were doing. 3D would be like on page 471, this example. So instead of just putting a dot right here at 38,000, and then a dot at the next one, a dot at the next one, then you draw it so it sort of looks like it's a folded piece of paper that is in 3 dimensions, sort of looks like that. And then connect those. And then that is a 3D graph. Now, the problem with this is when you see this part right here, does that mean you go across from here and it's just a little bit less than 38,000 for this salary? Or does it mean you go across from here and it's a little bit more than 38,000? So while the 3D graph can be visually a little more attractive, like these bales of cotton or whatever this is, it could be a little more fun to look at. It could be that it's more misleading and hard to read. So that could be a problem with a 3D graph. So these four look like they all represent 25%. But when you take that and you present it sideways like this, then D actually looks bigger, to me anyway. D looks bigger than either A or C. So even though A and C and B and D, all four of them are the same, when you put it this way, this one right here looks bigger. So that could be misleading. And then create a proportional bar graph. So this refers to exercise 8 in part A. A proportional bar graph, all the bars are the same height. I don't know why you would do that. How does making all the bars the same height affect? Okay, so now we need to go and look at part A homework. So this is number 8 in part A, and then it is referring to this information right here. Okay. So if you create a bar graph where all the bars are the same, so they had little eggs, and so one was that, so this was about the dollars distributed from a pension account. So this is, they had spent 8% of their pension. And then what if they spent 14%? And then what if they spent 18%? Well, I think that one's sort of obvious. Why would you make all of the bars the same if the numbers aren't the same? So these should be, this middle one should be bigger, and this one should be even bigger. CD. Hopefully you remember compact disc. They tripled from March to June. Is the following graph an accurate way to represent that? So they tripled from March to June. Well, if you look at it one way, the answer is sort of. The way that I'm looking at it is, if you ignore the discs themselves and you just look at the height, and then the height. So is this height 3 times bigger than this? So can I take these and stack them up once, twice, 3 times? It sure looks like it. So this height right here, then make the same height, and then make the same height. It's close. Not quite. I even think I made that one a little bit too big. But anyway, maybe that one's a little bit too big also. So, but that would be sort of close. But what people would look at is the size of the disc. And then is that disc, if you triple the size of that disc, is it that? And then it's also confusing because if you triple, there should be 6 of them over here. And there's only 2 of them. And then is this one 1/3 the size of that one, or is this one 3 times as one of those? I don't really know unless I knew what the radius was. Is the radius 3 times bigger? That is definitely a confusing graph. But it's basically meant to, someone will just look at it quickly and go, wow, in June, they either sold a lot of CDs or they sold some really, really big CDs. Let's see, number 13. A chest of 1,000 coins, gold coins, is presented to the king. The minter believes the king will not notice if only one of the coins is counterfeit. So I forgot to read the directions. Identify the population. So the population just means the whole group. Like if we were talking about Hartnell College students, the population would be all of the students. In here, the population would be all of the gold coins. And the sample is that 20 were chosen. So the king is suspicious. He chooses 20 and tests to see if they're actually real gold. So this is the population, and then this is the sample. What about number 15? So basically, they're asking you to look at both of these graphs. So even without reading it, you can see here, they're all about the same. Yeah, they go, it's a little bit bigger. And if you look at these, then this really stands out. Los Angeles, and they're talking about the average number of days where the smog levels are above standard. So unhealthy smog, Los Angeles really stands out. So then they're saying, get the numbers. So for Bakersfield, then that looks like, I'm guessing that's at about 25. Fresno, that looks a little bit smaller, so that's approximately 18. So Los Angeles, that's about 150. New York, that is around 16 or 17. And Houston, just a little bit smaller, 15. So estimate the values from each graph and combine them. So for Montreal, that is, looks like it's 14, and this 15, and then 16 and 17. So then combine all of those numbers and make a single graph. And when you go to make the single graph for this one, for one thing, it should start at 0. It's going to have to go up to 150. So maybe go by tens. 10, 20, 30, 40, 50, 60, 70, etc. until you get to 150. And then I would put them in order from the smallest. So this would be Montreal. And then that would go up to 14. And then there would be Toronto. And then there would also be Houston. And they go up to 15. Did I go by tens or fives? Oh, I went by tens. Oh yeah, so that's 15. And then, so then it would be, so that's 14. So 15 would be just a little bit bigger. This one would be the same. And then by the time you get to Los Angeles, then its bar would go up to 150. And then you would just see the bars get bigger and bigger and bigger until you get to Los Angeles. And number 17. So they ask you to look at this graph. The average carbon monoxide pollutant concentrations over the years from 96 to 2004 in parts per million. And they did start at 0, so I don't see a problem with that. Redraw the graph to emphasize changes and make the decrease more dramatic. So I could do that fast. So that's basically when you don't start at 0. So if I were to get a blank piece of paper and go like this and start the graph at 1, then the difference between this one and this one seems more dramatic compared to the original when you compared that one to that one. So that's if you were to start the graph at 1. If you start the graph at 2, then this one looks tiny and that one looks like it's around 3 times bigger than that one. And if you start the graph at like 2.5, then that one looks almost non-existent, and then that one in comparison looks a lot bigger. So you could just like start the graph at 2 and then copy and paste and make that graph. And then this looks way smaller than that. And let's see, number 19. During the 80s and 90s, changes in the workforce, downsizing, and hiring of temporary employees. Job security became a significant concern, sort of like these days. So let's see. So the percent of employees that say their job security is either good or very good. And then they're comparing the management with the non-management. So in the early 80s, both of them were pretty secure, but there is this about 4% difference. And then the non-management is actually a little bit bigger. And then they just keep getting smaller and smaller and smaller. So redo the graph so the downward trend is less obvious. So again, that is just shortening the graph. Doing it this way this time. And so the downward trend is less obvious. So that would mean this is the first one that's 79%. And then by the time you get to the bottom, let's say that because of the scale you use, then this is 51%. So then the gap right here between these, so if you follow this and go up, there's this much of a gap between them. And then if you look at this is the gap between them now. And I guess I should have made this one a little bit bigger to make it even more obvious. So you could just draw this one a little bit bigger and then draw all of these so that they're a little bit closer to each other. And then that will make it look like there's not such a big difference. Make it look even worse than it is. So that would be like, now this isn't really the way you're supposed to use statistics, but their point is that people do this. So this could be the 79% that's at the top. And then by the time you get to the bottom and you draw the 51%, you draw it like this. And then it looks like there's this huge gap between them. Okay, so that's an overview of the homework of 10.2. Hope to talk to you again soon.